Right, our learning target is I can write the equation of a transform function given its description. Okay, so what we need to know, the general function translations, just a little reminder that when we have an outside transformation or translation happening, it affects the vertical direction of our graph. And if it is inside, it's going to affect the horizontal. So what I mean by that, here's my function f of x. The k is clearly on the outside of f of x. So when I add or subtract k, I'm moving up or down k units. Another thing to be aware of is that when we're moving in that vertical direction, that the sign tells the truth. Okay, so the sign indicates our direction. If you're in my class, I talk about Hank and Kelly for H and K, and we talk about how Kelly tells the truth. As opposed to Hank, Hank likes to lie because if you notice here, we're now inside the function. We're adding and subtracting H from the X in the function, and we move right or left here. But if you'll notice, if I have a minus H, that would typically indicate we're moving in the negative direction, which would be left, but it's actually in the positive direction. So the sign is opposite of the direction, okay? And then lastly, we have our vertical and horizontal stretch and compressions. If we have our compression factor on the outside or a stretch factor on the outside, that indicates a vertical stretch or compression, and if it's on the inside with the X, that's going to be a horizontal stretch or compression. So let's look at some examples here. So describe the transformation on the graph given that the parent function is f of x equals 5 to the x. So we're starting here with every single problem. Okay, so if we look here first at this description. So it says we want to move down 2. Well, utilizing my rules, if I want to move down 2, we're talking about the k direction, so that would indicate that I'm going to be subtracting k. So I would just subtract 2 from the end of my function. So f of x equals 5 to the x minus 2. Okay, well here I'm moving up 6, so this would indicate that I would be adding k to the end of my function. So again, I'm just going to have that 5 to the x, but this time I'm going to add 6. When you're moving in that horizontal direction, that one's, I think, the easiest because we just add or subtract a number at the end of whatever function we were already given. Okay, then sometimes we're asked to move left or right. So if I'm moving left, this is when it's impacting what is inside with the x, okay? So if I'm moving left, I'm actually going to be adding. Remember, this is opposite of what we see. Okay, so I would be adding h. In this case, my h is 4. So when I get to my function, it would look like this. F of x equals 5 to the x plus 4, because I'm actually, that transformation, when we're shifting horizontally, it impacts the x directly. So if I'm moving right, remember, again, it's opposite. Okay, so we're going to have x minus h this time, or x minus 7, and it's going to be in that exponent part because I have to apply that directly to the x. Now, what happens if I want to do both? If I want to move right 8 and down 1? Well, I know if I want to move right 8, remember that's opposite, that would be my x minus h, or in this case, x minus 8, and then down 1, I would just subtract the 1 from the end of my function. That's my k, my minus k. So it would look something like this. 5 to the x minus 8, and then all minus 1 at the end. So this part is describing my movement right up there in the exponent, and the constant here at the end, this is describing my direction up or down. In this case, it's down. And remember also, just a little aside, when we are looking at exponential functions, this number at the end, that also is my asymptote. So when you graph it, you would see that the asymptote is at -1. So if I want to go left 3 and down 9, left 3, this would be an x plus h situation, okay, because those are opposite, remember, and then down 9, I would be subtracting k. So 5 to the x plus 3, that describes my movement left, and then minus 9 describes my movement down. So my asymptote would be at -9 here. And then lastly, we have right 5, so that's going to be x minus 5, and then up 7, that was going to be that plus 7 at the end. So there we go, 5 to the x minus 5 plus 7. All right, another example, if you would like to pause and try this one on your own, this one's got an extra kind of a little bit of detail involved than what we just did in the last example, but it says to write the equation for g of x, describe the transformation. So f of x equals 3 to the x plus 2. This is what we're starting with. This is our original function, okay? And now it's telling us that we want to apply the transformation. G of x equals f of 2 of x, okay? So this means that we need to replace or put that 2x everywhere in place of the x in our original function. So this x right now is going to get a 2x instead. So I just literally pick it up and plug it in. So g of x is going to equal 3 to the 2x plus 2. And there's nothing here to simplify. I don't have any like terms or anything. But you would want to make sure that everything was simplified first. It is, so that is my final answer. And here, this is just a difference of the two graphs. So g of x is compressed horizontally. We're describing what's happening. The graph appears to grow at a faster rate compared to f of x. And it's being compressed horizontally because we're applying that 2 directly to the x. So if you go back to your list of rules, let me show you that really quick. It'll take me a minute to get there. But here's that horizontal stretch or compression, okay? And we're applying that directly there. Okay, if you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.